Greetings, the Astro 30 here yet again with a brand new shiny video for you. Now, today I'm feeling kind of like a dinosaur. Just call me, I got a sore ass. Anyway, I've received a package today of some PCBs that I've ordered. I'm pretty sure I know which ones they are. I do have another package on the way. They probably won't get here till Monday. So without further ado, let's open the box and see what we've got. I always love opening PCB boxes. I think I've got an addiction to PCBs now. I don't know why. So, oh yes, well those are used for something else which are not relevant to this video at the moment, but they are relevant. But this is what I'm interested in. This is my bass / guitar preamplifier PCB for that speaker box project I was working on, and it is based on Elliott Sound Products guitar preamp. Now I'm not going to make this PCB available as a shared project on PCBWay simply out of courtesy to Rod Elliott, because he already has a PCB designed for his project, and I'll be taking away sales from him by people buying his PCB. Let's get this bubble wrap open so we can look at one of the PCBs thoroughly. And this has been sitting around probably for 2 months. Yes, I've scratched the desk. 2 months in my KiCad project folders waiting to be manufactured, and I just never got around to having the funds to do it or the time to actually go ahead and do it. Plus I had to move. So I put them to the side. That's the bottom of the PCB, because on this channel we like bottoms. And that's the front. Anyway, I've gone for board mounted pots. Looks slightly bowed, not too bad. Just for the simplicity of wiring, rather than, you know, having them off-board mounted pots like Rod's design is. I'll put a link in the description to the project that this comes from so you can look at the schematic. The only change I've made to it is I have removed the diode soft clip limiter that gives you the distortion when you crank up the gain control. For my purposes, I don't need it. So that's the only thing that's missing off this circuit is 5 components, a resistor and 4 diodes. However, I'll need to calculate how much these other capacitors I'm going to need to buy are going to cost me, because I don't have them right now. And I might be able to actually finish this project this weekend. Now I'm pretty much going to reuse these pots and sockets, which is just in the frame, these sockets here, on the new PCB, because, well, I've already paid for them once, there's nothing wrong with them, and this is no longer going to be used. So the parts are going to be changed to the PCB. So all I have to do is just basically unsolder all the wiring here. I'm not going to reuse the switch, which is another thing I need to just quickly bring up too about this PCB. There is a facility for a bright switch which goes where switch W1 or SW1 is marked. Now, it's not a board mounted switch, it's just a mini toggle that sits on the front panel with 2 tin pieces of copper wire going to the board. Now, in this build, on this video, I'm going to leave that switch off. I can just simply short across the 2 terminals here just to test the brightness function. Because I really want to have this mounted up against the panel first so that I get the length and the angle of the wires that go to the board correct, so they're not too short, not too long, and doesn't look wanky when it's actually mounted to the panel. So that's the only thing I am not going to mount on this board in this video. And the only parts I'm going to steal off of this assembled module are the 2 op amps, because, well, there's nothing wrong with them. As far as I know, they still work. So yeah, but I'll buy some new capacitors, and I've already got some IC sockets, and I should have all the resistors apart from these 2 1 watt ones. And of course the sockets, I need 2 pin headers. So I'll work out the cost of the capacitors and see if I've actually got enough money this week to assemble this board. But I'm going to take all the pots and input sockets off of this metal panel that goes into a server rack, and just reuse the parts. I'll even reuse the pre-made socket here for the power. I've just got to reverse the connections around, that's all. Alright, so for the first part of the assembly I'm going to remove all this wiring off these pots and input sockets and stuff. You may be saying to yourself, well, wasn't this a complete waste of time? Well, kind of yes, kind of no. Yes, I paid, I think it was $20 or something for this blank panel, but yeah, it's only $20. All I've got to do is just, you know, unsolder the wires, reuse the pots. All good, all is good with the world. So that's what I'm going to start with now, is just going through the task of unsoldering all the wiring and cleaning up the terminals so they fit through the PCB. I've got to re-straighten the terminals now. And all this wire that's left hanging around, I'll find use for that later for other things, so it's not going to get completely wasted. That was the ground or shield connection of the twin core audio cable that I used to hook up the input sockets. Look how oxidized that copper's gone already. Wow, it's only been sitting around for about 3 months. Damn. Okay, everything's been reclaimed and cleaned, and the legs straightened on the pots. I'm just putting everything in the board now just to see how things line up, and it looks pretty much like these pots, as long as when I go to solder them I make sure that any extra solder that's left on the other side of this pot is melted. Everything will mount on here just fine and line up just fine. One of these sockets might have to sit up at a slight angle off the board just to bring it into centralness, but everything looks fine. So yeah, it's ready for assembly. I know the hardware items like the pots are going to fit. They're all still marked on the back here as to what they are, so it's not a great big deal as to which pot goes where, but everything's marked. Everything fits. Wonderful. Okay, there's just one point I wanted to bring up, and we'll move on to assembly. Over here we've got something marked pot ground. What that means is we take a piece of this tin copper wire, solder it here, and then solder it across the top of each of these pots that go down the line, just to act as a ground for the pot, so it stops it from picking up noise when you bring your hand close to it. There's another ground over here which goes to the ground of the power supply, or the case, star ground. So without that connected, this is not going to work. So now it's on to assembly. I'm going to start in the usual order, which is resistors first, the low profile ones, IC sockets next. I'll put a PCB pin in for the normal ground. Other than that, we'll get started on that. I believe I've already got a 2U2. I think I do. Just looking around here, I don't have any 1U microfarads though, so I'm going to stop calling them U. It's mu, not U. Anyway, let's get on with it. I did notice one more thing, that this input socket is quite far back from the edge, maybe about 1 mil back from the edge of the PCB. I may have to put a washer on the inside of this to make sure that it brings it flush with the panel in front of it, so I'm not putting stress on the PCB or the components. I'm not sure about the pots yet, whether or not they mount flush with the front panel. From what I can see, which is not much, well, if I take that out, kind of looks like it does. Okay, all the resistors are installed. Well, the half watt ones anyway. I haven't got these 268 ohms, which are out of shot. yeah, these two yet. I'll get them later this afternoon. So now what would be a good idea would be to move on to the IC sockets, because whilst this board is not populated with high components, it's easier to keep it flat when you're going to solder, because I'm just doing it by hand on the desk. Yeah, so let me find two 8-pin DILs. So I ordered these on eBay a while ago and ordered 10 of them, and for some reason he sent me 20. Oh well, I'm not complaining. So I just need 2 of these if I can get them out of the tube. 2. I think I paid a whopping $3 or $4 or something for this lot. I can't remember, maybe it was $9, but yeah, ended up with 20 of them, and the order does say 10, so buggered if I know. Okay, so I put the packet back where I found them so I can lose them again. And I will install these IC sockets. No, they both stayed in there. Oh, how good am I, just ask me. Alright, so what I'm going to do is I'm going to solder 1 pin. Just holding it flat. The same on the other side if I can get it to go flat. This is kind of awkward with a camera tripod in the way. Right. And what we do is we just check the other side, make sure they're actually straight and not crooked, which they are, so I can solder the opposite corner of each, like so. And then make sure that it remains straight, which it did. And now I can just go down the line soldering out the rest of the pins. Which is much easier with this than a tip, I must admit. Now, I'm not going to take much video of this because what's the point? I mean, it is kind of boring watching an assembly of a PCB. However, I don't want to do time lapse either because that takes a lot of processing rendering time to speed it up by, you know, 600, 700%, whatever it is. Alright, so there we go. The IC sockets are installed. The next thing I'm going to install is the PCB pin over here. And, well, that's about all I can do for right now until I get the rest of the components I need. So I'll install a PCB pin wherever they've gone. Come out. There we go. I need the one. There's only one ground connection apart from the pot ground. Put that in, and that was a total fail. That works better. Alright, solder him in. Okay, that is soldered in. Perfect on the other side. I'm not even going to bother to trim that. So there we go. We're probably halfway through the assembly, so I'm quite happy to see this much project progress. As I say, I just need to get the capacitors, the Zener diodes, the 2 connectors I need. I've got the pots and the input connectors, even though some of the pins on these are a little bit crooked now. Once it's soldered in, it should be alright. Alright, moving on. One day I was walking and I found this big log. And I rolled the log over and underneath was a tiny little stick. And I was like, that log had a child. Anyway, it's the next day and I have to be a little bit quiet because no one else is up yet. I've been to JCar, I've bought all the components I need, capacitors and the resistors and diodes, and cost me a whopping $6.90. Yay. Alright, so next thing I'm going to do is start with the low profile capacitors like the MKTs, the two ceramics. Then I'll put the connectors in, I've got them as well, and then move on to the larger electrolytics. I thought it a good idea to install the large 1 watt resistors now before the MKT capacitors. I might install the diodes. You'll notice I've got an air gap there. That's intentional. Penis. Right, the MKT capacitors are in now, and the diodes. Now it's time for the connectors. That didn't work out so good. That's alright, I'll fix it in a second. Done. Now it's time to move on to the electrodes. There's all the electrodes populated and the polarity observed. It's starting to resemble something like a completed circuit board. So now all I've got to do is do the pots. Now with the pots done, I'm going to have to scrape off a little bit of the top of this metal here with a file so I can actually solder the shorting wire that's going to go, or the grounding wire across the top of the pots to it, otherwise it won't take. Also, this little location peg is no longer needed, not for this application, so they can be broken off. Oh, they usually break quite easily. This one doesn't want to. Let's try it with a pair of side cutters. There we go, that's all I needed to do. Pots are in and are reasonably straight. So now, well sort of, so now I need to put the pot ground wire in. Should have probably used my other tip for this. I said tip, not tit. Trying to get heat into both at the same time is awkward. Okay. Right. Just give it a little bit more heat, a little bit more solder, and I think I'm satisfied with that, but they're soldered. They certainly look like it. This stuff's expensive. It's like $12 a roll, and you only get like 25 grams. Now we can move on to the input sockets, and then this assembly is complete. They're all soldered in. It doesn't look too bad, and it doesn't look too off centrally either, so that should be perfectly fine. Now I guess it's ready for testing it. Make sure the actual thing actually works. Okay, I've done a little bit of work off camera and I've made up the DC supply cable with a connector. I had a couple of these spare anyway, so now it'd be a good idea to measure what the voltages across each of these IC sockets are between pin 8 and 4. We should have 30 volts DC. If we don't, we've got a problem. And before I do that, it would help if I connect the ground connection, or else it's not going to work. Right, so let's plug it in. So between pin 8 and 4, we should have 30 volt. Indeed we do on that one. And the second one. .30 volt. Excellent. Okay, got the oscilloscope set up, oscillator, the op amps are in. I'm using this as the output cable. I can't remember which end I had problems with in the first place, where the crimp pin is not actually making contact properly inside the connector. Oscillator's hooked across the low input and each tone control set to the center, so we should have an output. Op amps are in, so plug it in and see what happens. Well, immediately I cannot see any output signal. I can now. We do indeed have an output though. It's just something is not remaining stably connected. However, with both volume controls wound full up, we're getting a healthy 20 volt out, and it's not even clipping. If I play with the treble pot, we can see the signal increases and decreases, so I know that's doing something. Mid pot increases, decreases, so that's doing something. Bass, we're not going to see too much difference on until I change the frequency, of course. So the brightness is doing something. Every time I talk it keeps moving. Anyway, we know it works. So I'm going to crank that down because those dropping resistors are starting to get a little bit hot. So I'll swap inputs to the high gain now, if I so can. There we go. Now that one will clip. So we're getting to 27 volts before clipping, so very, very good. And I've lost my input connection again. There we go. Sweet. Okay, so at 200 hertz roughly, the bass is doing something, albeit this input connection is not that great. Okay, I've got the preamp hooked up to the Sony stereo amplifier here because it's convenient. Got my bass hooked up to the preamp. Bass. Mid. Treble. Wonder why it's doing that. I think it's this ground connection. Stupid thing. Okay, I'm just going to swap inputs real quick. Yep, definite gain reduce. Cool. Okay, thanks for watching. No, you think I was going to leave you there? No, it works okay. It works as expected. It works like his original one does. These resistors do get hot under normal operation, so do these diodes. But yeah, it's hot to the touch, but I don't think it's going to get any hotter than that. All in all, it turned out rather nice. I'm quite pleased with the results. So I might sell the remaining PCBs that I've got for this privately. If anyone's interested, hit me up in the comments. But for now, I'm going to leave this video here, and I hope you enjoyed it. And if you did, please go down below and subscribe if you haven't already, and give this video a big thumbs up. Helps me to realise whether I'm doing something constructive or not. Anyway, this is the Astro 30 saying see ya. Thank you very much for watching. Have a great day.